Hello, everyone, and thank you so much for joining the session today. And welcome to our fifth session on AG104. Today we are going to cover networking aspect, and I would like to invite Neeraj to give the introduction for our today's session and with details about our group, and then we will start the session for today. Neeraj, can you please speak?
All right, thank you. So let me go ahead and share my screen. Give me a minute. Okay, thank you. Good morning, good afternoon, good evening, everyone. My name is Neeraj, and we have been conducting a session on Azure for, I think this is our fifth session. And in past, we have conducted session on EZ 900, and this is EZ 104, which is for Azure Administrator Associate. And today, the session that we are going to cover is Azure networking. Now, the whole concept of the session, the certification-based session, has come into reality. Is with the help of our Azure Talk team, we realize that there are a lot of job losses because of COVID and coronavirus. And we decided, is there something that we as a community member, as a community founder, can we do something about helping people reskill themselves and find a new job? And that's one of the reason is we decided we will go ahead and start this session. So as a part of this, we have already conducted four sessions. This is going to be our fifth session about Azure AZ104, which is Microsoft Azure Administrator Associate certification. Uh, And in case, if you have not heard about Azure Talk or Azure Easy, I highly encourage you to go to azureeasy.com, and that's where you will find details about our past sessions. So in case you missed our sessions, you couldn't attend previous four sessions, well, you will find all the details out there. Plus also you will find the relevant uh, registration link. So we also have three more sessions after this for AZ104 plus. We'll also have upcoming session on AZ400, which is Azure DevOps. So I would highly encourage you to all of you to go out there and check on it. We also have our Azure Talk Telegram group. That's something you should also be joining our. So this Azure Talk Telegram group is based on Instant Messenger, and we leverage Azure Telegram. So this is a community group. It's a free and you can join. If you go there, you can use t.me/Azure Talk, or if you go install a Telegram application, and then from there you can search for Azure Talk, and you can join our group. So please do join the group. And in fact, we will not be able to answer all the questions that we are going to get today. In case we are unable to answer those questions, please feel free to join the Azure Talk Telegram group and post your question there. So that's something I would really encourage. We have more than we are nearing 8,000 members. We have 7,900 plus members, and it's a community, so everybody contribute together. So you can ask your questions, you'll get answers, plus you can also help contribute others, answer any questions. So this community is very friendly, very helpful. So I highly encourage everyone to join the group. With that, let me introduce you to the Azure Easy team members. So we have I introduced myself. I'm Neeraj Kumar, and probably you could see me right now. I'm based out of US, and I'm an MCT, and I'm Enterprise Cloud Architect. And then I have Ram Murthy. He's based out of Bangalore. He's also an MCT and Microsoft architect. He works on cloud technology. Then we have Ashish Raj. You heard him. Ashish Raj is, he's MCT too, and he's a DevOps architect. Again, he's based out of Bangalore. Ram and Ashish both are based out of Bangalore. Then we have Vipin Jha. So he's an MCT trainer, and he's based out of Delhi. Then we have Girish. Girish is based out of Germany. Then we have Rahul Mathuria, who is going to be our speaker also for the today's session, and he's going to lead the session today. He's based out of Bangalore too. He's also MCT and cloud engineer. So that's the our part of our Azure AG core team, and these all sessions have could have been possible because of all their contributions. So all this team came together, and we are working together as a team, and that's how we are able to deliver these sessions to you. So with that, let me quickly. Sorry. So, I mean, I'm going to be your host for today's session, and I've been with Azure Talk, for last 3 years. I'm the founder. I founded Azure Talk, and when we started very small with 10 to 15 members, but then today it grew to almost 8,000 members. So it has grown organically, and I thank everyone who have been very active and participating, sharing their knowledge. So that's the objective of the Azure Talk forums. Then we have Rahul Mathuriyat. So he's going to be our session speaker for today, and I'll be assisting him. So with this, what I'm going to do is I'm going to hand it over to Rahul to share his desktop and then walk us through today's sessions. What are we going to cover? So Rahul.
Thank you, sir. Let me share my screen. All right, let me start it again. Thank you. Thank you, sir, for the introduction. And good day to all of you. I hope you already have a great weekend so far. So what today's agenda is and what we're going to cover is all about the networking. So we will be covering how we will be, managing the networks and configure the networks in Azure as a part of the today's session. So today's session is, revolving around the Azure networking, and the agenda is Azure Virtual Network, VNET Peering, IP addressing, NSG, Azure Firewall, the VPN Gateway, Azure ExpressRoute, and the Azure WAN. So these are the topics that we would be covering today. And before we'll start, the prerequisite which I require, or we expect to everyone to have to understand the networking concepts behind it, is that you should know a basic of TCP IP. You should also know the VPNs, like how the VPN work, the virtual private network, which actually lets you connect with the Azure. How does the firewall works? What is the behind? What is the basic concepts of firewall? Why we required to use the firewall? The virtual networking, like how we normally do the networking in on-prem, like how we do virtually. Now the encryption technologies, that's where the firewall also come into the picture, and we would understand how can you secure a network, right? So let's not waste the time and start the Azure networking session today. So components of Azure network. Now, whenever you go ahead and look for that, what Azure can provide you as a network perspective, or network prerequisites of it, or network components of it, like you have these many networks or these many components of network which can combine together, provide you the better network connectivity when you go ahead and connect with on-prem, right? So you have virtual networks, you have CDN profiles, network watcher, and many more. Like we're going to cover not everything, but for sure we will be touching most of them. Okay, so today's session would be revolving around this particular diagram, right? How this is in your on-prem. So this would be your on-prem, and then you have a VPN gateway connected over site-to-site connectivity. You have a virtual network in which you have multiple subnets. How you have the gateway communicating with the other subnets using the UDR. Then you have a spoke network also. We will have a VNET peering, explaining that as well. So what is virtual network? So what virtual network is, what, or how you connect on-prem to Azure using your site-to-site connectivity. How it is beneficial to have it is that so if you have a building, like if I'm saying, like if you have a building base is manufactured with the right materials, your building will it will not will be collapsed soon. So likewise, if you have a company which did not plan the networking architecture very well, It will have a diverse effect like connectivity issues. You have bandwidth issues and communication issues. Your application like SQL DB storage, PaaS services will have a similar problems regarding the connectivity and throughput. So it is very important for you to have the right networking architecture and plan networking architecture before you begin to create the virtual network. So virtual network is something which you create in on-prem. It's very similar to the term called LAN, the local area network. So you create a LAN, you define the address space for that, and there within that you carve out the subnet from there, right? It actually gives you the robust, the boundary for the entire networking Azure services to be combined within one network, right? So it is very important and vital for all of us to have the the good, the address spacing plan before itself, right? Now, network. So this is how actually the network, virtual network looks like. You will see the IPv for address spacing. We will provide the IPv for address space, which we will go ahead and I will go ahead and tell you that how you create that. But this is how it looks, right? This is your subnet is. This is your virtual network address space. You carve out the subnet from there, and this is how it looks. So now, what is subnet? So subnet is something which creates a logical boundary, for within your virtual network. So right now, if you have multiple Azure services or components or the resources in one particular LAN or local area network, there will be a collapse and you will not be able to segregate them. So subnet is actually helps you to segregate different resources actually. So if you have one virtual machine in one subnet, another virtual machine in one subnet, if you do not want to communicate both the subnets to each other or both the applications or the machines to each other, you can use a subnet segregation with the help of subnet. So subnet is something which is a part of VNet. You carve the address space from there.
So Rahul, one question. So what's the relationship between VNet and subnet? So you're saying I can have multiple subnet inside VNet or vice versa?
Yes, so it depends. It depends upon the address space, like how we had the VNet, right? So VNet, where you carve out, you decide one address space, like a Class A address space or Class B address space or Class C address space, right? So you define an address space that this is what we're going to use for the virtual network or for our organization to connect with on-prem organization, and those organization needs to have a different IP addressing. That way, you define the address space. From there, you carve out the subnet like this. So 16 is the bigger, 24 is the smaller one. So that's the reason you carved it out. You differentiate, you divide the VNet address space into multiple subnets. So if you want, right? So that way you can do it. So that's what I said. It creates a logical boundary across your resources. So you can, if in case if you do not want one of the machine to talk to another, you can use different components like network security group. We have firewalls, like which we're going to discuss very soon, right?
So mainly, so VNet, inside the VNet, you can carve out multiple subnets. So basically,
absolutely,
subnet inherits the address space from VNet, if I'm not
absolutely
mistaken.
Absolutely. So I will also give you one more example. Like in our daily day-to-day basis, we have a couple of computers, couple of laptops in our home, and we connect to the Ethernet network. We connect to a switch port, right? So that switch port creates one particular LAN for you, and these two and switch is actually giving you two different address spacing, right? And these two address space is in the same LAN but in different subnet, right? So that way you can segregate that two Ethernet cables going into the same device but two different ports. That way is the two different subnets. It's like a VLAN situation you have that way. So it's very important. It's very important to understand that how many networks you need in a one particular network. That's the reason the planning of the network architecture is very important. So the VNet is the very first thing which you need to understand, that how we go ahead and provide the IP addressing for that, right? So just to give a brief about the audience, that what exactly the LAN is the LAN is nothing but a collection of devices connected together in a physical location, such as a building, or office, or home. It's a very basic definition. You can have multiple computers. Just I gave you example that you can have 2 or more computers connected to a router via Ethernet cable. That's how the LAN defines, right? So okay, next I will go to the next slide. So is it clear, right? Now, subnets are assigned IP address by subnetting the VNet address space, which I have just described that. So this is how you define it. You will see multiple options in the subnet section, which I will describe it while we do the demo. Now, UDR. What exactly the UDR is, right? So the UDR is something which routes the traffic, user defined routes. It's nothing but the user who defined the routes for a particular resource, right? So how we will go ahead and use this in our day-to-day life, right? So we have created a VNet, we have created a subnet. Now the next thing comes is, if in case a traffic or a packet comes to the subnet, the resource which is inside the subnet, how does the traffic moves? Like that traffic should know, right? Like this is my destination. How do I reach from one LAN to another LAN? So that's the thing, or this is the this is the acronym that user defined route, or the resource which will help you to route the traffic from one particular point to another particular point, where the UDR can be useful. So most of the times when organization required to filter the traffic using certain enterprise grade firewall, as you see in Checkpoint, you have lot different type of firewalls you have in most of the organizations, right? They use it to go ahead and filter the traffic that this particular IP will be allowed, or this particular IP will be dropped in case the traffic comes from the unknown source, right? So what happened is, at that time, when you want your traffic to reach the gateway or VNet or the internet, you gave the direction using this custom routes, right? This is the custom routes which you use. Now, this is how the route looks. You have to provide the name, the address prefix. The next hop type is nothing but where you want your packet to reach, the next, and that particular device will decide where to push the traffic, right? So let me move further. And this particular UDR, or the UDR, can only be allowed at the outgoing traffic. It cannot be allowed for incoming traffic. So if I'm applying a UDR on a subnet, so if any packet reach from the on-prem via gateway, it hits the subnet. If you have a UDR on the subnet, it will tell that you need to go to this virtual appliance. So once you select this virtual appliance, next of type, it will ask you the IP of the virtual appliance, and the moment the UDR receives the traffic, it will push the traffic to the required destination. This address prefix is not the device or the next hop type IP. There is no reference in between them. The address prefix is nothing but the destination, which I will also describe that while we do the demo. Now, what type of UDR routes does this contain? System routes. The predefined routes in Azure Fabric means pre-applied to Azure services. Now, it is nothing but the routes which is already been defined by Azure that can be override, but this would be there always. That's a reason when if normally people, when we already see that in Azure, when subnet to subnet routing is allowed, right? Because these routes are already there in the service fabric or Azure backbone. It's been there. It's the software defined networking has already allowed these routes for a person, or for a particular resource to communicate to another resource. So if you see address prefix unique to virtual network, next subtype is virtual network. See, default route is internet. So that's the reason whenever you read the documents, right, it always says that Azure allows the outgoing traffic. That's the reason. And there is an SG also that is allowed. So these are the RFC 1918 IP addresses, which is nothing but the IP address which is allowed for you to communicate over the network. So if these are blocked, then you will not be able to use these IP addresses, right? So these are absolutely. These are reserved IP addresses which cannot be used while you're routing the traffic, right? Um, you can override these custom routes using the custom routes. What is custom routes? Custom routes help you override the system routes, and Azure always prioritize the route based on the routes that are associated to the subnet. Now, these are the routes which is provided by the customer. Like you create a route table, you provide a route table, a route, and you associate it to the subnet. These are the custom routes. Now you can override the system routes by using these custom routes. If you enable the border gateway protocol or custom routes with next hop type as VNet or gateway or virtual appliance, all the traffic, including to the public IP address, which is supposed to go over the internet, will go to the gateway, right? So if I say, let me just go back one more slide again. So if anything which is you applied on the subnet and that's supposed to go over the internet, but you mentioned that anything, this is called default route. When we say default route, which is this 0.0.0/0, anything will go over to the virtual network gateway. If the traffic requires to go over the public internet, this will go over the virtual network gateway and your packet will be dropped, right? So you need to make sure that the custom routes which you're creating should be very well defined, very well planned, so you can route the traffic to the right destination and associate the associate the network traffic UDRs to the right subnet. One more very important thing is you cannot allow or you cannot associate the default route to the gateway subnet. And if you do that, well, eventually it will not allow you to do that. But if you do that, it will drop the packet, right? These are the priorities in case if any questions come that what kind of how does Azure prioritize the rule is actually UDR first, which is user defined routes, nothing but a custom routes. Then you have a BGP routes if there is BGP enabled on the gateway or from the if there is an ExpressRoute connectivity you have, so that connectivity goes over the broader gateway protocol, right? So broader gateway protocol tend to go ahead and inform everything in the network that this is my network. You don't have to specify what is the network on the on-prem. So that's the specialty. But at the same time, if you don't want one of the Azure network to talk to on-prem, then it would be a problem. That's when the BGP routes come, so you can route in such a way that the traffic will not go to the unknown destination. System routes is what comes at the last. So if you enabled one more thing, just want to tell, if you enable the service point for a subnet, right? If you enable the service point is nothing but a traffic which goes over the Azure backbone, right? And you will allow that over the subnet level. So if you enable that feature, that any traffic from one particular subnet go over the Azure storage over the backbone of Azure, then these routes get override again. So service point get the more priority. I hope this is clear for you guys, and I'm not going too fast for that.
So Rahul,
Okay.
You mentioned about service endpoints. I think we are going to cover this in future slides.
I will not be able to cover the entire. It's not the service point of the private endpoints, but I will show that how does it look and how does the UDR affect that. So I will show that.
Sure, thank you.
So this is the question. User-defined routes applied at what? Is it inbound connectivity is applied at, or the outbound connectivity will it be applied at?
All right, so you can go to the question on website q.azureeasy.com/1. Again, the URL is q.azureeasy.com/1, or you can also scan the QR code listed on your screen, and you can answer. You can vote your answer there, and we will show the answer in a minute or so. So please do go to q.azureeasy.com/1, number 1. And we will also paste the link in the chat so that you can also access it from there. All right, so we have the link in the chat, so you can just go and go there.
Okay.
We still have 40 seconds to complete the. So we are still getting responses. 30 more seconds. Okay, responses are available. Rahul, you can open the response URL to show the answer.
Oh, like the Q is one. Okay.
You need to open it in browser. The answer is listed on the presentation as well. Yeah. So.
All right, it's good. So the answer is outbound. Maybe
It's not loading actually. Sorry. The answer is outbound actually.
all right. So as you mentioned earlier, right? So UDR traffic is meant for any traffic which is going outside of your subnet, right? So traffic generated by a virtual machine inside the subnet, trying to reach out that traffic. That's where the UDR will come into the picture, and you reroute that traffic to your next hop, right? So you know it applies to outbound. So that's something.
Okay.
All right.
So let me go ahead and start. So, so public and private IP address. What is public IP and private IP, and why it is actually useful? So, why did I say does it ring a bell? Is actually because you do see this type of connectivity and communication on a daily basis, right? You have a virtual, you have a wireless, communication or wireless router in your home, right? So you see that it does the job for you to convert the public IP to your private IP and connect you to the internet, right? So everything right now, what you're seeing right now is over the internet only. So why similarly in Azure, it is required for Azure resource or service to have a public IP. In order to accept traffic, besides Azure resources can communicate without IP, which is only the outbound traffic, right? So if you have a virtual machine like this host, it can still connect, over the internet, but nothing can be connected to that machine unless there is a load balancer to provide you, which again it uses the public IP for you to connect that, right? So public IP address is the address that is assigned to a computing device to allow direct access to over the internet, and it enables Azure resources to communicate to the internet, right? So Azure dynamically assigns a private IP to the Azure services. So you don't have to worry about like we have to assign a public IP. No, it will go ahead and assign a public IP for you. The resources which you use in Azure, is what type of resources are used by public IPs are virtual machine network interface. You have internet facing load balancers, the VPN gateways, application gateway, and Azure Firewall. So there are PaaS services and SaaS services also, but we are talking about the networking. So these are the actual components which would be using the Azure services for you. A resource without a public IP can communicate outbound, but as I said, it will not have an inbound connectivity. Now, what is private IP address? So any IP address that falls under the specified range, which is nothing but class A, B, and C with 10.172.192. Right? So you must have heard about these ranges before, right? These are the private IP addresses. They are non-routable on the internet. These IP addresses are reserved only for internal communication or only for private communication in the corporate network. It cannot be seen outside the network, right? So we're not going to get deep dive into it. What is a class A, class B, and class C? But yes, just for your reference, you can use it only for private network address spacing. So in case if you want to go out and search what A, B, C, please do so, right? Azure assigns private IP addresses resources from the address range that you provide while defining the VNet, like what we have defined, what we have seen before that, there is an address range space for 10.0.0/16. So anything which you deploy under that VNet or a subnet, it will fetch the IP addresses from there. So what happens is if you deploy a machine, the first 4 IP address for that machine for that subnet will be consumed by the Azure itself for the routing purposes, for DHCP and DNS purposes. But after that, you will have the rest of the IPs in that subnet will be allowed for you to use, for the routing purposes, like how the way you want to connect it, right? So these are the resources in Azure. A networking resources will have the private IP address, which is virtual machine network interface, which you see in public also, right? So you have load balancer, which you also see in the public. So there's 2 types of different load balancers you have, public and the private as well. You have application gateway. So application gateway also a private application gateway, right? It can be. And you have on-premises network through VPN gateway or ExpressRoute circuit. So how you connect with the on-prem network with the VPN gateway? VPN gateway behind that, you will also have the private network, because when you spin up the gateway in a gateway subnet, it also gets the IP address, a private IP address. Public IP address would be there, but you will also have a private IP address which would communicate with your subnet, and I mean within a VNet, right? There are 2 type of allocation
So,
we have.
Rahul, one question on
Yes.
the previous slide. Uh, so there we have covered, a very basic thing, like, there are 2 types of private IP address and the public IP address, right? So,
Yes.
and you have covered that, these are the 2 type, I mean, these are the different resource types. So how, how it gets started, like, as a normal consumer, how will I decide if I need a public IP address, or is it like private IP address? And what is exactly, from the beginner point, like, what exactly the need of private IP address, if at all we already have a public IP address? Is there any benefit of having a private IP address, or what is the cost associated and all those things? Is it like, costly private IP address?
Private IP, so anything which requires to be communicated. So private IP address, I will say, like, you have in your flats, you have a door number, right? So if in case if I want to reach your home, I need to know your door number. So private IP address something like a door number for you, right? Public IP address is also a door number, but over the internet, like it's a global network. Over the global network, if something needs to be reached, you need to have the public IP. Now, you said on the beginner level, as I mentioned, right, we actually do see this type of communication on daily basis. Live example is our wireless router, right? You will receive a wireless router from a broadband connection. that broadband connection will assign you a private network. But that wireless connection or wireless router or the broadband connectivity, right? That broadband will have the public IP for you to go over the internet, and
So
it will
it's
also do
like
some of filtering.
that until I am not going beyond my company network, private IP address will be able to suffice my
Absolutely,
requirement most of the time, majority of the time. And if at
absolutely.
all my network communication is supposed to go outside my company network, then definitely I might need a public IP address.
Absolutely. So, in one of the point I mentioned that a resource without public IP assigned can communicate outbound,
Hmm.
but it will not have inbound connectivity.
Exactly. So if I want someone to come to my network, and if that someone is outside my company boundary, then I will have to give him a public IP address where they can land, right?
Absolutely. Yes.
Okay.
Yes.
So
Absolutely.
yeah, and then what is the cost? Cost thing. Are you going to cover, or can you elaborate now? Like is
This
it? Yeah.
I would not be able to cover the cost part. Probably this is the networking and communicating like
Yeah.
connectivity
So
part I
as
have.
far as I know, private IP address does not have any cost component, right?
Yes, it will not. Yes, it
So
does
the
not.
only thing need to be understood from the beginner level that whenever you are going for a public IP address, be aware that there is a cost impact. But in case of private IP address, they don't really have to think about that aspect, right?
Yes, you are right. Absolutely.
Okay, okay. Yeah, let's thank you. Thanks, Rahul.
Yep. So yeah, so I was talking about the allocation method, that how a machine you can have the allocation types, right? As if there could be a static allocation, there would be a dynamic allocation. Now, static is something Azure assigns the next available unassigned or unreserved IP address in the subnet address range. The dynamic is the default allocation method. It always be default whenever you create anything, right? This particular toggle bar will always be there, right? So it will always be there. You can see here, right? So this will always be there. You don't have to do anything in that. Now, what is static allocation method? The static allocation method is something sometimes like a resource required to have the static IP. You do that particular resource should not change their IP always, right? So the current example in this situation, I can give you the application gateways, right? Because application gateway is actually associated with the DNS. So anyone who is hitting the application gateway public IP or the private IP, that IP is associated to the DNS resolution. So if there is an application gateway issue in Azure or anything goes wrong with that front-end IP of the configuration of the application gateway, it will impact the resolution and the reachability in the Azure, right? So that is one thing. So this is what static and dynamic allocation is. Now, how it is help you to communicate via public and private. So as I was mentioning before,
So,
right, regarding.
Rahul, if I may interrupt, so you talked about
Please.
static and dynamic, right? So,
Mhm.
what could be the scenario where you will use static versus dynamic and why?
Yes, dynamic is so if I say like whenever we create a virtual machine, right? Virtual machine will always have the dynamic public IP and also the dynamic private IP. It will You don't need the private static IP every time. So likewise, I will say PaaS services communicates over a public IP, right? And most of the organization are required to have a private connection to those services from a VNet. At that time, what happen is if those PaaS service IP gets changed, so there is a range of the IP address for the PaaS services Microsoft has. One particular region has a range of IP addresses. So those IP gets changed sometime. And you do not want that IP address to get changed in the middle of it while you
Okay.
having a communication. If that happens, you will lose the communication, right? And you do not want your customers to have the connectivity issues while they are reaching your website or they're reaching your
So
storage.
okay. So you're saying any workload which is exposed to internet, for example, a website, right? And you host it on a machine. Now that machine requires persistent IP address because your customers are reaching out on the same IP address, right? So in that case, you will use a static public IP address.
Absolutely.
And you have to make sure. So that's something probably we should be aware that if you have any workload which requires public IP address because your customers are communicating with it, make sure that you choose static public IP address as opposed to dynamic, because dynamic, it can change if your machine reboots. The dynamic IP address would change, right? So that's something.
Absolutely.
Okay, good. Thank you.
Yes, yes, yep, no problem. So I was talking about the how does that it actually leverages the PaaS connectivity. So PaaS service communicates over the public IP. We all know that, but right when you have or big organizations where they always needs to have the connectivity via the Azure backbone or something which goes over private. At that point, this service endpoint comes into the picture, and also it actually leverages the private IP communication. So that's the reason I added this point, that how is actually using the service endpoint in Subnet. This is how you enable it. So you see that these many options are there. Microsoft Storage, SQL, Service Bus, Key Vault. These all are the PaaS services which has the public IP, but most of the organizations don't require those communication to go over the internet when they are communicating via their private network, right? So that's the reason you use the service endpoints in here, right? So it is the very valid and the basic point to understand, and very good feature if you enable that.
So
So
you're saying, okay, so if I may interrupt, so you're saying anytime, prior to service endpoint, right? So that's a service endpoint was not in the picture. So prior to service endpoint, anytime you try to access any PaaS resources like Azure SQL, Azure Key Vault, or Azure Service Bus, or Azure Event Hub, the traffic from your VNet were always traveling on internet. Though
yes.
these two services were still owned and operated by Microsoft Azure, but the traffic was going over internet if you try to access any PaaS resources. Am I right?
Right. But I will explain one thing, just want to tell you that service endpoint is something where you still, the PaaS services like storage, SQL, these services will still have the public IP, right? That's the reason, like it's again the security flaw in case, there are companies which do not want that, these services to be exposed right over the internet, right? So what Microsoft has introduced is the private endpoint and the private link, which actually helps customer to make sure that the traffic remains on the Azure backbone. It will never ever go, over the internet using the private endpoint, not the service endpoint. Service endpoint does have the public IP, but if I say if a traffic or if a packet will host which is starting from Azure VNet and travels towards the Azure storage, which is in the Azure boundary, it will go over the Azure backbone. But what about the other traffic, right? It will not only be the Azure VNet traffic, right? What about the other traffic who like the customers who wants to access those services outside the Azure boundary? At that point you may need the private endpoint.
So
That's
mainly,
that's one of the
so
feature.
you so you're saying that if you had any resources inside VNet and that resource is trying to access any PaaS resources, then service endpoint will make sure the traffic gets routed over Azure backbone, right?
Yes.
But
Yes.
let's say if you have services sitting on-prem, okay,
Mhm.
and that service or that resource is trying to access your PaaS resources,
Mhm.
in that case, you will use private endpoint. With the help of private endpoint, you will be able to route even that traffic, your on-prem traffic, using Azure backbone to your PaaS.
Yes. Yes, absolutely. You can do that. The private end, that's the reason private endpoint helps a lot of customer and has been the most popular service right now in Azure.
Thank you.
You're welcome. So, all right. So I hope this is clear. Just to explain again, it enable the VNet to communicate with services like storage, SQL on private network using Azure Backbone, and it amplifies the security posture for any organization for you, right? These features. So you definitely need to consider that. Now, VNet peering. I hope Good, and we are all on the same page so far. Now, why VNet peering? When Azure launched VNet to VNet communication using the VPN gateway, right? Many customer has provided a feedback that even we need to communicate VNet to VNet, like one VNet in one region or one subscription. You need to still create a gateway, right? You need to pay for that gateway, and the connectivity is still over the internet, and there are more charges, right? So why VNet peering? How does that VNet peering came into the picture? And this is the reason. You don't have to pay more. Now VNet peering enable two VNet to connect to each other. They will able to communicate without having a VNet gateway. You can use two VNets and you can use one gateway at the same time, right? So basically the feature for the gateway or the Azure VNet is that you cannot have multiple gateways with one virtual network. You can only have one gateway. Now, how does that two VNets will communicate to on-prem using one gateway? That's not possible, right? So this is the reason that Microsoft came up with this feature. VNet peering enables you to use one gateway and use the Azure backbone to route the traffic from your spoke, hub, wherever you are, right? So this is the feature for the VNet peering. The reason is, the customer do not want the traffic to be presented over the internet. Hence, they introduced the VNet peering. The network traffic between the peered virtual network is private. Traffic between the virtual network is kept on Microsoft backbone network, which is very important to know. No public internet, gateways, or encryption is required in communication between virtual networks. So we can connect across subscriptions and across regions as well. So we have, Microsoft has also introduced their new feature, which I will tell you again. But there is no charge of create VNet peering. Data transfer will be charged. VNet peering enables two VLAN communicate with each other. I'm explaining thing again. So with the diagram, you will now be able to understand that. What happened is behind the picture, if anyone from on-prem or the network engineer has joined, he can easily relate that. Two VLANs communicate with each other. Two VLAN or a VLAN or a LAN becomes one. It actually appear as one to the on-prem gateway or on-prem device who's trying to communicate with Azure. So it is actually one LAN. It's a big one LAN, right? So that's a good feature for VNet peering. Now, VNet peering has two types, which I was saying that is global and the regional. Now, global is like you can enable the global peering across subscription and across regions as well. If this particular VNet is actually in East US and this is in West US, if you have the global peering, you can have this feature enabled. Regional is something within the same region you can enable the regional peering. Now, important to understand that if VNet A is paired with VNet B, and if VNet A is also paired with VNet C, it doesn't mean that you can communicate this way. The transitive routing or the transitive peering connectivity is not possible in this situation. You still have to do something which is like connect these two again using the gateway because the peering is not possible.
Rahul, sorry to interrupt you. So like you're talking about the gateways. So let's just assume like I have several virtual network within the same region and I want to have communication between them. So do we actually need gateway in those scenario also?
Like several virtual network in one region?
One region. So I have VNet 1 in one region and in the same region I have VNet 2, VNet 3. And later on, I have a requirement to communicate between some of those virtual networks. So do we actually?
Yes. Sorry. So this is why the regional peering comes into the picture, right? You do not need a gateway actually. There is no gateway required to communicate different or multiple VNets. Yes, there is a limit for one virtual network can be connected, but you do not require a gateway to connect. It's only required on the one VNet, which requires to be communicated with on-prem network. Is it clear?
Okay, yes, clear.
Okay, all right. Peering whereabouts. So what is the features and the whereabouts we have in the peering? So first and foremost, important feature is the gateway transit. Gateway transit is VNet peering property which enable one virtual network to use VPN gateway in the peer virtual network for cross-premises connectivity. Now, I will explain you that what exactly the gateway transit is. Let me go back one more slide again. When you enable the peering, right, it will always ask you that if you enable the peering here, it will ask you that do you want to use the remote gateway or not. So if you click on remote gateway, right, it will let you connect or let you flow the traffic from here to here, right? Now, what about this guy? What do you need to enable here? You need to enable the gateway transit on the hub actually. Gateway transit will let you pass the traffic, or let's example like spoke 1 or spoke 2 traffic from spoke 1 to on-prem. If you don't enable gateway transit for this gateway for spoke 1, it will not let you pass the traffic. It will allow the traffic since you use the different options or different features in VNet peering, but it will not let you pass the traffic to on-prem. So that's the reason you need gateway transit option to be enabled where you have a gateway, not where you don't have a gateway, where you have a gateway. So that is the one feature. Another feature is allow forwarded traffic. You can enable the the traffic between the VNets, like from hub to spoke to hub. That depends on you. That's the reason you enable it. You should enable this particular feature. Don't disable it, otherwise the traffic will not go through. Use remote gateway, which I explained you that this particular option needs to be enabled on spoke. It actually saves cost. You don't need a gateway. That's the reason you're using the hub gateway, right? Now, what are the benefits? The benefit is nothing but low latency, high bandwidth, connectivity between the resources in the virtual network or in the Azure boundary. One particular virtual network can communicate with other resources in different virtual network. You can have the different type of connectivity or data transfer between Azure subscription, different tenants, models, regions. So it's a pretty great feature to have it in your organization. Most of the organization does have this. All right, so now we are coming to network security group. Network security group. Now, by the name itself, you now understanding that it's something related to the security, right? Well, when we deploy anything to the cloud, requires to be in the network for anyone to communicate. Hence, the network are the entry point for your application. They should be the first line of defense, right? So, for only accepting traffic from users, application or protocol which has been explicitly approved, they only can be do that, right? So, if you allow these kind of firewalls, you can only allow the traffic which you accepted or which you allow it on the rules section. Firewall, network security group, ACLs, like on-prem guys must have heard about ACL, right? Access control lists. A lot of people have configured the access control list on the Cisco devices as well. So what they do, they have always followed the tuple configuration. The tuple, I mean about source, port, source, destination port, and the protocol. So what does Microsoft does is Microsoft is actually simplifies the virtual network security through the management layer, which is nothing but a network security group. Now, as the name suggests, it secures your network, and this group is actually built on 5 tuple program, which I just said: source port, destination port, and the protocol to allow and deny the traffic. Now, I will explain you that what ports are. Ports are nothing but the so if any application requires to be listened on one particular port, you enable that on the network security group. The protocol is nothing but TCP, UDP, the different type of ICMP, other type of protocols, you can enable them. Source is nothing but from where the traffic is actually coming in, right? The IP address, or maybe anything. Destination, where the actual traffic is reaching to. Does that port needs to be open? So that's when the inbound and outbound security rules comes into the picture. Containing the list of security rules, allowing or denying the traffic connected to the Azure VNet. Anything which is in the VNet, you allow on the subnet, you allow on the NIC or the network interface of the Azure virtual machine, you can use this network security groups. Now, network security groups works on priority, which means lesser the number, higher the priority. NSG contains default rule enabled when a network interface gets associated with. So these are the default rules and the priorities which we have, right? So I will explain you that. What you let me give you the very general example in case whenever you go ahead and deploy any virtual machine, these network or these security groups, you will always see that on your without declaring anything, like I was explaining in the UDR section, that they are system routes, right? Azure has already known that you need to have these system routes to be in place for you to communicate or for you to route the traffic the same way. In order to just to secure traffic on a general basis, Microsoft has provided you a basic level of security groups which will allow you to communicate within the virtual network via load balancer and with blocking the internet incoming traffic. So virtual network traffic, the traffic originating and ending in the virtual network is allowed both inbound and outbound direction, which means let you connect within the subnet or within the virtual network. Internet, it's only allowed in outbound. Inbound is always blocked. That's the reason a machine, and I was explaining you that in the public IP section or private IP section, that a machine can have the outbound connectivity using the private IP, but they cannot get anything out of it, right? So anyone who needs to communicate inside, they will not, because this is there. The general rules are there, right? Load balancer. This will actually, the load balancer, when you deploy, so Microsoft also has the load balancer in his SDN, right? So that is actually the IP address of 168 or 129.24, some IP is there, but I'm sorry, I forgot that. But that is the IP which actually probe the health of your VM instances, which is in the virtual network. If you block this, it will not go ahead and let you, check the health of the machines. And that's the reason you might have seen on the portal also that, check the health results of this resource, gateway resource, virtual machine resource, right? So this is what it allows you to go ahead and check that. So these are the default rules for inbound and outbound, and this can be override. So you don't have to worry about it. The priority starts from 0 to 65535. You just need to remember, the lesser the number, the higher the priority. Now, NSG enforcement. How does that NSG enforcement works? Like now you must have a question that, okay, we understand that there is a there is a default rule, there is a security rule already there. Okay, fine, great. Now, how do we apply it? Where all it does apply it, right? So for inbound traffic and outbound traffic, you already know that yes, we need to apply an inbound and outbound. How does it apply on inbound and outbound? Anything. So you create a virtual network here, right? You create a subnet here. So subnet 1, subnet 2, and subnet 3. Now anything which is inbound, right? And you applied an NSG, like NSG1 in this picture. You applied an NSG, and anything which is coming from the internet, that's on TCP port 80. If NSG1 allows that traffic, right? Remember, allow the traffic for TCP port 80, it will let you go. Besides, if this NSG doesn't block it. So let me repeat it again. If anything which is coming from internet inbound, NSG1 applied on subnet, and there is one more NSG which is applied on network interface. So two ways you can apply the NSG on two levels, on subnet level and the NIC level. Now TCP port 80 is allowed on NSG from the source, which that you can use your computer's IP also. So you allow that, but you denied all of the traffic. But what happened is, if you don't allow anything on NSG2, it will drop the packet. This is for inbound, right? By the way, NSG is stateful in nature. What I meant about is stateful, that if you allow the traffic, right? If you allow the traffic on the subnet, you don't have to allow the same traffic or same port or protocol on the network interface, right? So what I meant is, if you allow TCP protocol port 80 HTTP, right? Allow on the subnet level, you don't have to allow on NIC level. Now the outbound traffic. The same way, if the traffic from the virtual machine needs to connect to some website, right, bbc.com, this has been allowed here on the NSG2. But if the traffic is not allowed here to go over the internet for that specific website on that port, right, it will be dropped. So this is very important to understand, that whenever you create rules, right, it's always it is always actually not required to have multiple NSGs on NIC subnet at the same time. But in case if it is required, make sure that you do not block anything at the NIC and allow the same thing on the subnet level. You need to allow the same traffic on both the sides. If for the same traffic you're creating the rules, right? So that way you need to be very careful while creating the NSGs. So I hope this is explained very much clear. Just want to give you the tips on this. When you're planning an NSG, right, you only have to worry about the IP address which are assigned to your business, which means that you can ignore anything assigned to an Azure infrastructure, such as DNS, DHCP, etc. Like normally what we do in on-prem, right? We configure the DNS IP also, we configure the DHCP IP addresses as well. We configure the different storage IP address. We configure the the routing protocols also, like from this particular checkpoint to this particular. So you don't have to worry. If it's been taken care by the Azure itself. So similarly, if you're using load balancer, you only need to worry about the source and destination of the computer or service, not the IP address that's used by the load balancer itself. You don't have to worry about that. Microsoft covers that. Azure has this feature.
So Rahul, if I have some NSE at the subnet level and one NSE at the virtual machine level, virtual machine NIC level, okay, and the same subnet has several VMs. So do you want to say like we should allow common traffic at subnet level, and specific to the NIC, we need to configure at a NIC level NSG? Like if I have some traffic to communicate on entire subnet, we should allow that ports at the subnet level. And if it is something specific to my NIC, we should allow or block that traffic at the virtual machine level, virtual machine NIC level.
Yes.
Okay.
So specific. If you want to go with the specifics, like if in case this, like an example I'm giving you, subnet 1 has 2 machines, right? Now, anything which is coming from the internet on port 80 requires to be communicated with VM1, but not with VM2. But you have already allowed the NSG1 that we have port 80 on the subnet level, right? It has been allowed. Port 80 has been allowed on the subnet. Now you do not want this VM2 to communicate, or anyone from the internet communicate with the VM2. You allowed the NSG2 stating deny port 80 from anything over the internet.
Okay, it could be either internet, or if I have several VNet on cloud, okay, and we have the communication between those VNet. So it could be within those VNet also, right?
Absolutely.
Right. So it may be with internet, and it may be within the virtual networks as well.
Yes, internet is just an example I'm giving you. I'm giving an example just because it would be easy to relate for people to understand. But source is not just an internet. Source can be anything. It can be a laptop IP also. It can be the VNet IP also. From VNET Peering, right? Like if we just an example, just what we have learned about VNET Peering, right? So Spoke can communicate with Hub. Now, if I do not want one of the subnet in Spoke virtual network to not communicate with Hub virtual network, I can deny the traffic from the entire IP address of the subnet range of Spoke, right? So that will drop the packet. But otherwise, the other subnets can still communicate. That
okay.
way.
Okay.
Makes sense, right?
Yes.
So by that, we have a question. So do you need NSG to be allowed on NIC and subnet simultaneously for same port and protocol? Just as an example, you can use true and false and let me know. I will show you the answer for that.
So you have 60 seconds to answer this question. You can open browser and type this URL q.azureeasy.com/2. You can scan this QR code from the browser and answer this question. For 60 seconds, Rahul will show you the result.
And I just discussed the same point we just discussed in the last slide, so I hope the answer should be correct.
And we have also posted the question URL in the chat. So if you can click on this link, you directly open the questions actually. Yeah. We have 50 seconds to go. Twenty more seconds. Yeah, Rahul, you can go to the answer slide now. Answer is available to the participants.
Okay, so that is false. So as I said, it's a stateful in nature. NSG is stateful nature. You don't need to allow the same port and protocol on subnet as well as on NIC. Azure understand that you already allowed on subnet, you don't have to allow on NIC. But we discussed in the last slide, right? That if there is a specific traffic or specific machine do not need to be allowed for that protocol or port, you please block it on the NIC or on the subnet the way you want, whichever the traffic inbound and outbound, depending upon the situation.
So Rahul, would you please a little bit explain about the stateful? What does it stateful here means?
Okay, so stateful is nothing but when you say about stateful feature, the stateful is nothing but the traffic which is how do I explain that? So if any inbound traffic, right, which is coming to the subnet and is going out of the subnet, you don't need to allow that particular port or the protocol TCP or port 80 to be allowed on subnet as well and the NIC as well. It will automatically replicate, or it will automatically tell that stateful nature of that traffic will automatically tell that the rule is already allowed on the subnet. You don't need to have the rule to be allowed. It will automatically communicate the rule to the NIC. That's what the stateful feature is. Stateless are designed to protect the networks based on the static informations. That's the reason it requires to have the to have the source and destination allowed on every hop of the packet from subnet to NIC. If this is stateless feature, right? If the NSG is a stateless feature, you need to apply the rule on subnet as well. You need to apply on the NIC as well. When the outgoing traffic would be there, then you need to apply on the NIC and then subnet. So it would be very messy and the difficult to understand that. I believe it was a similar way in older ASM ASM services, but not in the ERM services. It's been like it's much more easy to understand that.
So with ASM, you want to say like the classic model, right?
Yeah, the classic model, yes, absolutely.
Okay.
When we say that these as ACLs, right? When we see the access control list at that time, this is what I was talking about.
Okay.
So stateful is nothing but a pretty advanced. So most of the firewalls have the stateful nature only. They don't want to replicate multiple rules in the same time. So that's what the stateful is. Make sense? Can I proceed?
Okay. Yes. Thanks, Rahul.
Yeah. Okay. Again, the tip. Again, I just want to give you. I know the NSG is a little bit tricky to understand, but the tip is when you plan NSG, you don't worry about the IP address. Make sure you are worry about the ports and protocols. You don't have to worry about the IP address. The port and protocol needs to be allowed in such a way that the Azure would understand that what needs to be allowed and what do not need to be allowed. And if it is Azure, you don't have to allow any load balancer, DNS, DHCP, nothing, right? So this is the very important tip. Please remember that. Now talking about the stateful and stateless firewalls, here we have Azure Firewall, right? Wow, this is the advanced feature, better than NSG, but still not the very much enterprise level of what we have in market today, right? We have a lot of Palo Alto, Checkpoint, and other firewalls. They are the enterprise based, right? But this is still again a very good feature, a very good add-on for you to secure a network, for you to secure the network devices, right? So it's a very important feature. Very important to understand that how can you use it, what is the functionality of the firewall, and let's proceed. So most of us will start to think that why we now require a firewall when we already have NSG, which blocks the traffic on 5-tuple basis. I explained you that. Isn't that enough? And I guess it's not enough. Hence, an NSG is a firewall, even though a very basic one, albeit a very basic one. It's a software-defined solution that filters the traffic at the network layer, NSG. However, Azure Firewall is more robust. It's a managed firewall service that can filter and analyze the traffic on layer 3, layer 4 traffic, right? Layer 3, which I mean the network layer traffic, and layer 4, which I mean the TCP and the UDP layer traffic, right? So port traffic, as well as layer 7 traffic, which is the topmost layer, application layer traffic, right? So this is the huge advancement from the NSG which Azure came up with. And trust me, it's a pretty good and heavy built feature in Azure right now. Azure Firewall is actually a public facing and is responsible for protecting an inbound and outbound traffic for the VNet, right? This feature likes to have like application rule. It has SNET, DNET, kind of rules in it, which is very handy for you. So you can see that it's protect the virtual network resources. You have fully stateful firewall service, which we discussed, built-in high availability, unrestricted cloud scalability, support high available firewall clusters. So when you go ahead and deploy Azure Firewall, it actually load balances itself, right? So you can route all internet bound traffic to a designated next hop. So it also do the forced tunneling for you, right? It has inbound DNET and outbound SNET support. But by that, what I mean is it's actually do the NAT for destination, and outbound traffic, it will do the source NAT for them. Which I mean, like if anyone who wants to communicate from the internet, you need to go through the Azure Firewall. Azure Firewall has a public IP. You hit that public IP. Azure Firewall in turn, translate that public IP to the private IP of his network, where you deployed that, and send the traffic to the destination which you want to, like which you told him to, like your wireless router, right? It has the threat intelligence based filtering can enable for, it also has threat based intelligence. I don't want to read the entire thing, but threat intelligence based filtering is nothing but if any threat coming up, accesses attack and the cross-site scripting attack, sorry, it also gets filtered, right, for inbound and outbound access. So it's also help you to protect the domains as well, right? So if you do not want certain domains to be accessed from your network, from organization like any Facebook or any other network like social media network from your organization, you tell them that particular subnets that, just block it. It will just block it. So so you can route all internet bound traffic to the designated next hop. It is compliant to payment card industry, which is nothing but PCI industry, which is like, you provide your card information. So those firewalls which they use is the PCI compliant. Otherwise, no company will use it. You need to use that. SOC, it's a service organization control authority, which actually, see that like what sort of services is there in that particular organization, whether is it in the level of the security compliance or not. Then it is also ISO. I hope everyone knows that, International Organization for Standard, ICSA labs, and HITRUST. HITRUST is nothing but very much compliant with OWASP kind of mod security rules. So it has been completed. It is really good feature in Azure, which has been compliant with the enterprise grade security, which you find in most of the enterprise grade firewalls in today's date. You may want to use NSG if you're protecting a network traffic in and out for a subnet, but this is where also provide you more secure environment. And it trust me, it does. People started using it. Rules are needed. Definitely, they are needed. NSG has rules. This guy also has rules, right? So if VM in a spoke subnet requires to communicate over port 3389, and you have a jump box in the different subnet, what you do is you just told that jump box subnet to go over the Azure firewall, to go outside. You don't want to send traffic over the internet, don't send it, just send it to firewall. He will decide using these rules whether you need it or not, right? Before I will go with the rules which is required, Azure Firewall is highly available solution. Just want to tell you that, and it's also required to be created like the gateway subnet what we had. So when you name this, when you create the Azure Firewall subnet, which I will show you how you create that, you need to provide a name specific, which is Azure Firewall subnet, and make sure the IP addressing the range which you give to the subnet of Azure Firewall, it should be /26. As per the Microsoft saying, or the Azure, Azure saying that you need to create the Azure Firewall in a totally different VNet, but for testing purpose, you can have in the same VNet. Most of the time, I've seen it when we create the Azure Firewall in the same subnet, in the same VNet, like a hub. What happens is the traffic gets into the loop and it gets dropped also. I'm sorry. So NAT rules. So the rules are, what are the rules? Like same way what we have in NSG, it's exactly the same way what we have in NAT rules. Inbound internet network traffic to your firewall IP address is translated, which means your public IP, any traffic from internet hits the public IP of Azure Firewall, it actually translated to the private network of the Azure Firewall. So it has two NICs actually. You don't have to create two NICs, so don't worry about that. It has two NICs. One for receiving the traffic from the internet, which has the public IP. It converts the traffic and sends it over to the private IP where you have deployed the Azure Firewall, right? It has network rules, which allows the traffic, denies the traffic based on the service tags also. So it has service tag feature also. FQDN feature is also there, but it will come up. It is in preview actually. Network rules is always applied before the application rule. So the application rule is there where you can have the DNS systems and FQDNs, allowed. But if there is any deny in network rules, it will be dropped. The bracket for application will be dropped if the network rule denies this traffic. I hope this is clear. It is not that difficult, but it's exactly the same. The priorities like the same way, lesser the number, higher the priority. The same way it is here as well. I will show you that how you will allow it. There are different, there are not many tabs that you need to understand it, but these are the rules which you will see while creating the Azure Firewall. Okay, so we are now coming towards the gateway feature. I will continue, or should we provide a break?
So Rahul, I think we should continue for all the concepts, and post that we can plan for break.
Okay, okay, makes sense. So Azure VPN Gateway, what is that, and why you need it? A door to connect, right? So it's exactly the door that you need to connect with, right? So just a basic example, or a very lenient example I will give you. If I want to connect, or if I want to reach out or ask something to my neighbor, I need to knock the door. That knock will only be understand, like that person will only understand that if he gave me his contact number or the door number to reach out to. So that is the door that you knock. Only you know the public IP address of the VPN gateway. So VPN gateway is nothing but a virtual network gateway which provides you or sends the encrypted traffic from the Azure Virtual Network Gateway to an on-premises location over the public internet. That's the VPN gateway for you. So you can use the VPN gateway to send encrypted traffic between virtual network over the Microsoft network also. So that's what it means. You have VPN gateway here. It has a public IP. You have on-premises. It has a public IP. Behind that, it actually has its private IP, which will communicate, right? So this is the door number. These two are the door number. These are the guys who wants to communicate, right? And this all goes over the internet, right? So the same way it is. So okay, let me complete this. I will explain you one very important point. The virtual network can only have one gateway. I explained you before as well. It will composed of 2 or more VMs that deploy to a specific subnet called gateway subnet. So this is very important. This is very important. When you create a gateway, right, you have multiple SKUs, you have multiple generations, right? And it also, when you deploy a gateway subnet, right, when you create a gateway subnet, the size of the gateway subnet you provide, that subnet will allow you to create those VMs. And it also depends upon the intern, actually, not it also depends, in turn it depends upon the SKU in the generation of the gateway. So that is very important for you to understand that you should have the gateway subnet specifies in such a way that your connectivity throughout the like the site-to-site VPN connection will not drop. I mean the throughput, the bandwidth you require, that depends upon it. So if you define this smaller gateway, right, like /28, which is very small, right? So what happens is, when you want to have more throughput towards the gateway, what happens is you will you will not be able to create it, because in a gateway, when you create a gateway, right, it's nothing but a software network device. It's a software network device. It's deployed on the core, it deployed on the Azure Service Fabric. It's not a physical device. So how does that gateway will be so capable to communicate with the on-prem? It only be capable when it has multiple virtual machines in it. So it does has virtual machines. Those virtual machines will be very powerful machines depending upon the SKU you choose. So this is very important to know that. It actually takes 45 minutes to complete, right? So when you create a virtual network gateway VMs are deployed to the gateway subnet and configured with the settings what you provided to them. Now, when you create a VPN gateway, right, you can create using IP. It actually creates over the IPsec VPN. So I will go over the type of Azure gateways also, but we need to understand that the communication which is required is actually on IPsec IKE VPN tunnel. That particular protocol, you can say the protocol, yes, it actually used only for IKE. It's Internet Key Exchange. It's called Internet Key Exchange. It works on the port called 179. I did not mention in the slides, but it's important to know when you troubleshoot the traffic information using Wireshark, right? What happens is you will see the communication from the private IP address of the gateway on port 179, even though you don't see it over the private IP, but you will see the port. That way you will know that yes, the traffic has reached your side or not, right? So that is very important to know. Now, the type of gateways you have point-to-site VPN gateway. This gateway uses, like at what time you use this gateways? You use this gateway at the time when you have multiple clients who do not like. I'll give you the very vague example is Starbucks, right? You have Starbucks. You have different type of coffee channels, right? We have shops which open their network. That's called point-to-point connectivity. That's called point-to-site VPN gateway. When you create that, you need to have that VPN gateway can have multiple point-to-site connections, and they can have different VPN clients. You need to be, but there is one more thing which you need to understand. That's a vague example I'm giving you that, but when in organization it comes into the picture, right? There would be a specific IP that you would connect. VPN gateway will have a certificate to authenticate you, right? Because it actually requires you to understand that the security of it. You just can't go ahead and just tell that, oh, I want to connect with something. VPN gateway, just give me a VPN, I will connect with that. No, you need to have a certificate which authenticates your client. I mean your laptop or the device with which you're connecting to, right? And then you will connect to the VPN gateway and the network behind the gateway. That way you can connect with it, right? Now, the second thing is VPN gateway, which is nothing but site-to-site connectivity. So connection over IPsec, which I just said, Internet Key Exchange, can be over IK v1 or IK v2. So this would be an IK v2, okay? The point-to-site VPN gateway. There are different type of features like SSTP tunnel also, which we will not be covering that right away, but you need to know this, right? IK v1 and IK v2 is the VPN tunnel, the feature that you will connect with the on-prem devices. It requires a VPN device which also supports the same type of feature. So if your VPN gateway is an IK v2, the on-prem VPN gateway also needs to connect on IK v2. The same way, if this is an IK v1, this also needs to be on IK v1. Now this is ExpressRoute. ExpressRoute it's a high bandwidth connectivity on-prem connection, right? When someone says that, so most of the organizations, big organizations, definitely it's actually a costly one, but it is what people or most of the big organization uses it. This provides you the high availability in terms of the connection. You can have the border gateway protocol used in this picture. Even in VPN gateway, you can also use it, but these kind of devices is preferred to use border gateway protocol. It's actually based on MPLS connection. It provides you the really high bandwidth on the private network connection. It doesn't go over the internet. It's private, right? So these are the three types of Azure gateway that you use in Azure Microsoft to connect with on-prem. Now,
so
it depends
Rahul, sorry to interrupt you. Means ExpressRoute, you're saying the high bandwidth. So high bandwidth is just because it would be using a direct connection, dedicated line from on-prem to the Microsoft Azure data center. Is it right? Is my understanding correct?
Yes. So when you okay. I thought to explain you lately when we were discussing ExpressRoute, but since you asked the question, let me explain that. So when you go ahead and when we go ahead and thought about the ExpressRoute connection, ExpressRoute is not exactly the VPN. It has the Microsoft Edge devices, right? It has the Microsoft Edge devices which will connect to the customer provider Edge devices. Those Edge devices has a different type. So when you create a gateway, right, you need to, instead of selecting or toggling in between VPN and ExpressRoute, you should choose ExpressRoute. ExpressRoute will give you an option that the features that you will go ahead and have it to provide you the high bandwidth. The moment you select the ExpressRoute gateway, it will spin up the ExpressRoute devices, right? It will spin up the ExpressRoute devices connection from the Azure gateway to the Microsoft Edge devices, which you cannot see it, but yes, that's happening in the backend, right? So this is what happens in the Microsoft Edge devices connected to the Azure gateway, which in turn connect to the partner Edge devices. The entire traffic, which I said in the beginning that the VPN goes over the IPsec protocol and then the port 179 is important for you to know and troubleshoot the traffic. This particular guy or this particular feature will, what you do is how you will troubleshoot the traffic is actually to know that the AS number, this autonomous system number, is actually 12076, which is important for us to troubleshoot that. If in case there is no connectivity or the BGP routing is not happening on the Microsoft, we should see whether ASN number of Microsoft Edge devices is configured in the partner Edge devices or not. Because the moment Microsoft should I explain? I'm just going to go ahead deep dive in this, but this is the benefit for this. It actually works on layer 3 connectivity, right? So it also has a global connectivity.
So I think my question was only to understand, like VPN will go over the internet and ExpressRoute will have a dedicated connection. That was only my question. So I hope you answered that. Is that my understanding correct, right?
Yes. So it is.
Okay. Absolutely. Okay. Thanks, Rahul. You can carry on.
Thank you. So gateway SKUs. Gateway SKUs, it's important for throughput purpose. I was explaining in the beginning also that how does that a gateway will spin up virtual machine in it. So you need to be very specific about the SKUs as well. The generation one will have a basic, the maximum connectivity would be 10. The point to site connections would be 128. The P2S V2 open connection, open VPN. These days, open VPN connection is also coming up in the picture with the point to site, but it's not supported yet. So in basic, right? So you have different type of generations as well. You have different type of SKUs also. VPN GW1, GW2, 3. I did not paste the entire picture here, but when you choose, when you create a gateway, right, at that time you will see that there are different type of generations and the SKUs available for you. So with that SKU, the average throughput or the benchmark will also increase. The properties will also increase, but you need to specify the gateway subnet as well because it spins up the heavy virtual machines as also. Need to be dealt with meticulously, as I said. Very careful. Be very careful when you choose the gateway SKU. Because if you choose the gateway spin-ups, you will not be able to delete it. It will consume the cost. Because when you choose the high bandwidth gateway, it is not cost effective, right? So the connection limits are separate. Example, you can use 128 SSTP connection and 250 IP2 connection on VPN gateway 1 SKUs, which gets increased again with the different SKUs. So SKUs, selecting the SKUs are very important and understand, just to understand that it's very, very important to be dealt with the /26 you want to give for the gateway subnet or not. Gateway types, policy based and the route based. So policy based is nothing but IKE V1 traffic. So IKE V1 is something which connects with one, I will say, with one on-prem site only. I mean, not just one. With the one-on-one traffic selector method will only communicate with like 10. If you have the VNet, which is communicate with 10.1, and then you have on-prem site which is 10.2, it will communicate over the VPN connection with that particular IP address only. It will not communicate with the anything. Which if you don't define anything in the address space of the local network gateway with which Azure needs to communicate, it will drop the packet. Hence, the address of opposite VPN devices needs to be specified. The route-based gateway selects the traffic selectors any to any. You don't need to specify everything right away. When you define in Azure Gateway that these are the address spaces, anything which is coming under to that particular address space will be communicated. It's a wildcard. It chooses these the traffic based on the wildcard. So that's the reason it will automatically automatically update the routing table and the forwarding tables as per the IPsec tunnel. Now the gateway subnet, which is very important. From the beginning, I'm saying that how you deploy the VPN gateway. This is the first point that you should be applying the VPN gateway. It is recommended that you should have greater than 28/28 subnet, should not have lesser than that. In any which ways, even if you're choosing basic SKU also while creating the gateway, you have to have the /28. It is always good for you to have the /28. When you create a gateway subnet, gateway VM will be deployed as per the SKU you select while deploying the VM. I explained you that. Now, local network gateway. Now you must be thinking that, now what is this local network gateway coming into the picture, right? Why the local network gateway we have? When we have VPN gateway, we have IKE V1, IKE V2, two different types. Then ExpressRoute gateway. What does this local network gateway do? Local network gateway represents your on-prem configuration. How does the Azure know that, oh, this is the device IP, the on-prem device IP, this is the on-prem device subnet. So local network gateway is only used for the information or the configuration details about your on-prem. Azure VPN Gateway connects with local network gateway to establish the connection with Azure over IKE and IPsec tunnel. You need to furnish all the details related to on-prem, which is nothing but address space of your on-prem VPN gateway public IP. All right, so we are now at the third question, and the last question also. Choose the type of VPN gateway. What are the types of VPN gateway we have? Application gateway, local network, ExpressRoute, and the VPN gateway. Please answer this and choose the. So it's a multi-choice question. Please select the one which are right. So ready, guys? Started that.
Rahul, let's proceed with the answers.
Okay. So the answer is ExpressRoute gateway and the VPN gateway, which include the pointer side as well. But VPN gateway has different type of gateways we have, like V2 and IKE1 type of features. In that you have IPsec. ExpressRoute gateway, we also have a feature. So application gateway is not the gateway like VPN gateway. It is a gateway, but it will help you connect on the layer 7 protocol, and it also does the load balancing kind of feature. Local network gateway, which I explained you that it will you need to have it in your, you need to deploy that just to provide the information of the on-prem. Okay, so the big topic. What is Azure ExpressRoute? Right, so the wide area network, if you heard about the WAN, right? When we talk about the customer, I see that more customers are moving away from the classic MPLS connections, the dark fiber networks, if you heard about, right? So these terms which which will scare most of the people, like MPLS, BGP, dark fiber, VRF, those things, those technologies will actually combine together, and this is what you get. Private dedicated lease line will not go over the internet. Connectivity from any to any VPN network, point to Ethernet network, and virtual cross connection through the connectivity provider at the co-location facility. These are the three different features. I will explain you in a bit. Okay. So Azure ExpressRoute service lets you connect to your on-premises network, network co-location to the Microsoft Edge network via private connection between you and connectivity provider. When I say co-location, right, the co-location is nothing but the provider which has those devices, like the devices capable of handling the BGP network, MPLS connectivity, WAN connectivity. They can host those devices within their on-premises and let you connect with Azure. And they should be the connectivity provider of Azure. The Azure should knowing them very well. That then only you can go ahead and connect them. So what with ExpressRoute, you can either access Microsoft Azure services or even Microsoft 365 services, right? So we do have different type of peerings that would be enabled in Azure ExpressRoute, right? So that you need to be aware about. So these are the three type of connectivity models what we have. Co-location, which I just explained you that. The co-location is nothing but a provider which hosts those devices which will let you connect with Azure ExpressRoute. Point to Ethernet. Point to Ethernet, let me explain you very on-prem manner. When we say the point to Ethernet, I hope you have seen those ADSL, the ports in your home, right? And before what we have, so there would be a box, a telephone box where you connect your ADSL line. That's point to Ethernet, and that box will be connected to the broadband network. How? Through the interwire cablings. Like you may have seen it, but these days everything is under the table. But this is how the point to Ethernet is. Microsoft Azure stretches their network to the point where it can provide the network. So that's what called point to Ethernet. Now, any-to-any IP VPN connection is nothing but you have a big BGP MPLS WAN connectivity, and multiple sites connected to that particular WAN, and you have one more the site connected to that WAN, which is nothing but your Azure. So Azure will also act in a similar way as a site, like these sites. These are all connected on BGP network only. They are not connected on VPN. They are all connected on BGP. Wide area networks only work on BGP. So this is also one site. So any-to-any IP VPN is nothing but an MPLS connectivity which will provide you. Right. So this is all about the ER connectivity model. How does that connectivity works? It's pretty difficult for me to go ahead and do the demo on it, because it requires to have the the provider service. So I will tell you one more very important point, that whenever you go ahead and deploy the ExpressRoute circuit, right, there would be one service key who gets generated every time, which is required for you to give it to your provider with whom you want to have the ExpressRoute connectivity. That service key will create the one-to-one mapping on it. One-to-one mapping is very important for VRFs. VRFs is nothing but virtual router forwarders. That means when you have, so if you see these are the multiple sites connected to one WAN, right? This particular guy can send a traffic to this guy. This particular guy can send a traffic to this guy. This would be a mess if everyone starts sending in traffic. It will act like a hub. There is no, so if you send one message, it will broadcast to everyone. So this is not what you like to have it, right? So this is why you have one-to-one mapping. In that, you have virtual router forwarding options enabled. The virtual router forwarder will have the IP addresses and it will provide you a single key. A virtual router forwarder will provide you a single key, which will tells that this is this customer and this is that customer. So route the traffic in such a manner, right? So this is the method or the connectivity models that you have. Azure ExpressRoute has different type of peerings. It has ExpressRoute peering, it has Azure private peering, and it also has it has Azure private peering and Microsoft peering. Before, if someone already worked or before someone has worked on Azure ExpressRoute, they must have know about a public ExpressRoute as well. So a public peering as well. So public peering was always dealt with the public or SaaS or PaaS kind of services, but everything right now is included in Microsoft peering right now. As I said, like you need to go ahead and understand that, but these are very broad concepts of BGP. That how does it work? Azure private peering is actually for virtual machines, cloud services that are deployed in a virtual network. So it always connects with a virtual network. You can set up the bi-directional connectivity between your core network and Azure virtual networks. All right. Microsoft peering is actually for Office 365 was the connectivity to Microsoft Online Services. That is also enabled bidirectionally between your WAN and Microsoft Cloud Services. So that is one, the two peering models that we have, and sorry, two peering features we have, and three different type of models. The way which the organization wants to connect with, you can connect that. So now that's this leads us to the last topic, that how and what is virtual WAN. Recently introduced a very powerful feature which most of the customers required, that they was always asking that why this Azure virtual WAN. Right, Microsoft has introduced this feature very recently this year. What is actually the Azure virtual WAN? So what I was discussing in the third model, if you clearly, if you have seen that model, it has a WAN in between, like a big cloud, right? Everything, different sites are connected to each other, and they are all working on BGP. They all have the different type of connectivity models. You can have the MPLS, you can have VPN, right? That kind of big cloud is exactly the same. The on-prem SD-WAN feature, they have deployed it in here in Azure. Azure Virtual WAN is nothing but a big MPLS connection, a big MPLS connector. You can have MPLS, you can have ExpressRoute gateway, you can have point-to-site gateway, you can have VPN gateway connected at the same time to the same WAN. Components of WAN will be there. It's a region specific. You will have a hub in it, right? In one hub, you will have different type of gateways, all the type of gateways you can have, point-to-site, ExpressRoute, and site-to-site. You can deploy multiple hubs in it. You can have the same, the hub-to-hub connectivity, which will lead to a very important point, that in VNET peering, in ExpressRoute, or in site-to-site connection, customers were struggling to go ahead and connect to have the site-to-site connectivity. When we talk about the ExpressRoute, right? Let me go back. Just sorry. When you have ExpressRoute, when you have two different sites, you have connected with these two ExpressRoute with the two different sites, right? This side or that side. What happened is, if this is also connected with the ExpressRoute, right? What happened is, if this customer, the customers, stayed here, wants to go from here to there, or what happened is this is creating a big latency, right? And what about the customer wants to go directly from here to here? It is fine, but how about the customer wants to reach this way? This is creating a latency. That's when the AS number, the autonomous system number, the gateway priority, the weight which you need to provide, the inconsistency in the routing creates. And this is why the WAN is very important. WAN, what a WAN does is you create different type of hubs here, You have the connectivity, you have different type of branches on-prem. You use the way you want. You want client remote users to connect with the virtual network or the on-prem side. Use this way. You go to hub, you route the traffic, you come here. You go to hub, you route the traffic, you come here. If you want, what you do is this remote user using the pointer side can reach to VNet also. This guy can reach to VNet also. Now, this also branches can have similar kind of connectivity. You don't need the VNet to branch connectivity right now, like how the connections were there, right? Like when the Azure initially launched with the VPN Gateway features, right? Most of the customer says that how does the internet connectivity works? So we normally says that to the customer, you know what? You need to do it everything here. The routing needs to be done here on your router devices. So the traffic from Azure will go here and you route the traffic that way. But not now. WAN will give you this particular feature, will route the traffic from here to here, here to here, right? So you have MPLS branch also. If you have SD-WAN branch, MPLS connectivity, use ExpressRoute, send it to the other branch, which does not have the ExpressRoute connectivity, which may be connected with the site to site also. You can move the traffic from one hub to another hub, one region to another region without using any other gateway, right? And I did that. It literally works. I will give you. You might having a question, but I will that if we have multiple VNets that every single site can connect to each other. Where is segregation? How can we control the network? This is not the best way to secure the traffic. I will come to the point for sure. So just to complete the PPT, this includes branch connectivity via automation from virtual WAN partner devices. So virtual WAN will only work with the partner devices that you have. Site-to-site VPN connectivity, remote user VPN, you can connect, as I explaining that before. You can have transitive connectivity, which was not available at the time of VNET Peering. Now, if you connect these two, right? So here, let's not talk about the on-prem, but let's talk about the Azure itself. This VNet A or VNet B is connected to the hub, Azure hub. So this is the major component where everything would be there, right? So you need to create a gateway, you need to create in a hub. WAN would be the big cloud, which will consist hub, right? So you have a hub here from VNet 1 to VNet 2. If you want to go, you go through hub. In this, you don't call VNet peering, you call VNet connection. You create a connection to the hub and hub will route the traffic automatically. You can also see the effective routes. You can also create the UDR in here as well. You can have the Azure Firewall also, but you cannot create any other devices like NVA, like how we create in virtual network, right? You cannot create the NVA here. You can only deploy Azure PaaS service, which is Azure Firewall as of now. Microsoft is coming up with different concepts right now. They have virtual hub routing also. They have site-to-site connection and they have VNet to VNet connection, segregation as well. They have introduced it recently. So yes, so VNet 1 can communicate from one hub to another hub in different region without having a gateway. You don't need a gateway. It's just direct. It will not. You don't need anything. You can isolate VNets if you want to. And there is a shared services. You can have the routes. You can create the NVA not in hub but in your VNet, and then from there, what you do is you create the UDR in here and route the traffic to NVA. NVA will go ahead and balance out your traffic the way you want to. So this is all about the private connectivity Azure WAN will provide. So yeah, we are at the end of the session. We would be doing a demo after this, which would be we will be creating a VNet hub spoke architecture, provide the VNet peering site to site. We will create NSG firewall UDR to restrict traffic. We will deploy VM and check connectivity across the network and internet, right? So a good time to break.
Yeah. So yeah, Rahul. So everyone, we will take a short break for 10 minutes, and then after 10 minutes, Rahul will come back and will show the demonstration of the listed labs. So it is going to be a complete lab session for all these topics and hands-on. So be there, take a break, for 10 minutes, and then come back after 10 minutes. Yeah, thanks, Rahul. You can put
Thank you.
yourself on mute and we can come back. Yeah, thank you.
Okay. Hello.
Yeah, Rahul. Yeah, let's. You can take over the. Yeah, you can start your sharing, and yeah, we can start the demo session now.
Okay. So the foremost thing which we will start with virtual network, how we will create the virtual network. We have so what you need to do is you need to first go ahead and select on search bar, or the moment you log into the Azure the Azure portal, you will have on the left navigation pane you will have these resources that you want to create. You create click on create resource, or you can type virtual network right like this, and then you can create, or just type virtual network here like this, right? So you go ahead and create a virtual network. What you need to do is you need to click on add. You need to create a resource group. If you don't have it, just click on create new. It will let you create a new resource group. So like right now I have multiple resource group. I can select any one of them. So if I go ahead and create this, just select on-prem VM resource group. You go ahead and name the virtual network the way you want to, like I will say VNet 1. The region, so you will have multiple regions, the way which one you want to choose depending upon your on-prem network. And so you can reduce the latency as per the connectivity, right? So you can choose anything. You can click on next IP address. The IP address this is where you will provide your address space for the network which you want to create that. So this is the way you want to create that. You choose a network in terms of class A, also class B as well. So it is not that you always needs to go ahead and choose 10.3, right? So once you choose this, once you create this, once you enter the information here, you can have multiple address spaces also, right? Like if you do 10.4.0.0/16, right? So you can have multiple address spaces as well, depending upon your need, out of which you can go ahead and create the subnets, right? So this is where you go ahead and create a subnet. Mostly what happens is when you go ahead and create a virtual network, it actually creates a default subnet by yourself. If you don't want it, you can click on default. You can change the name, subnet 1. You can change the IP addressing as well, the way you want it. Now, I was discussing about service endpoints. From here itself, you can choose about what service endpoint you want to. So like if you want to go ahead and create Microsoft storage, you can choose that. But this is not the session for service endpoints, so I will not create anything as such. All right. So this is how you create a subnet. You can add more subnets also. If you want different subnets, a part of this default one, you can have this. Click on security next. This is you will get 3 different options. A Bastion host, if you want to enable the Bastion host in it. If you want to enable the DDoS protection, the standard protection also, you can enable it. This is how you create the Azure Firewall, right? If you want to create right away, you can create it by enabling the Azure Firewall. You can name them. You can create the subnet. You need to provide a different subnet range actually, as I mentioned before. So you can create that, but not now. We're not creating this right now. Tags. If you have any tags to differentiate your, to differentiate your business continuity, you can have this. Now, once you create it, it will do the final validation, and you can click create, and it will create the network for you. I will not create this because I have already networks created here. So I will go to virtual network. I will show you that how does the virtual network looks. This is what it looks like when you create the virtual network. You will get this right at this point. Now, these are on the left navigation pane. You will see address space. You can check what all address spaces are there for your virtual network. You can also see that connected devices you have in this virtual network. Right, so this has a network interface, a virtual machine, a network interface, NIC card, and this also has a gateway. So this is the type which you see, right? If you go to subnet, you will see the default subnet, which we already see while creating a virtual network. You can add more subnets by clicking here, which is exactly the same way. Let me show you one more time. So you will have a subnet. You will put the subnet name. If you want, you can have the NAT gateway, but that you need to create it. So don't worry about it right now. You can have a different type of network security groups. If you have any network security group, I was explaining you that you have network. You can have network security group on subnet level, and you can have on NIC level. This is on the subnet level. You can associate that. You can have the route tables also. So if you have any route table created in your portal or in your Azure subscription, you can associate that depending upon the situation as per your business need, right? These are service endpoints. I was explaining it before as well. And this is the services that you want to delegate. This would come with the feature of private endpoint. So don't use it right away. Now, gateway subnet you created right now, it is showing grayed out because I already have the gateway subnet. Make sure the name of the gateway subnet is this way: gateway, capital G and capital S. I have created the gateway subnet with a range of /28, as I mentioned, not lesser than /28. You can have the route table also associated to it. Service endpoints also associated with this network. DDoS protection, it was asking you to enable it. So if we did not want it right now, it will cost you also if you have this. Azure Firewall, you can create it from here also. Security. This is the Azure Security Center, which we will not dive into this. So these are the virtual network features. Service endpoints also is here. Private endpoint is also here, which if you want, you can create that. Peering also we have. We will also go into the peering. So I have created the hub and spoke architecture, which I showed you in my slides. Then I have one spoke network and one hub network, right? I've connected them. So hub and spoke network, this is how you connect. You go ahead and type the name the way you want to connect with. It's like hub to spoke or spoke to hub. From where you're connecting right now, I'm connecting from hub to spoke, so I've named it as hub to spoke. It is not, it is not that you only have to write hub to spoke. You can write anything, right? There is no constraint in it. You choose your subscription. You choose your virtual network with which you want to connect with, right? So right now I want to connect with my spoke, so I choose spoke. I have already created the peering with this, but that's fine. Like I'm just want to give you an example, right? Now it will give once you okay. Let me see if there is anything which I can. Okay, no. Okay, so test VNet is the extra VNet I have created right now. So I have chose this one, and now you name the peering name from the spoke to hub. On the top we have created peering name from hub to spoke. Now it should be spoke to hub, right? So I was talking about the configuration in peering time, right? So you have a virtual network access. You need to enable this. So your virtual network or subnets or machines or the resources can access anything from hub VNet to test VNet. You also need to allow from test VNet to hub VNet. If you disable it, it will block the traffic, right? Forwarded settings. You can forward the traffic. If you want to forward the traffic, you can use this option to forward the traffic. So you also enable this. It is always a good option to enable that. Gateway transit option. In hub, as I mentioned, in hub where you have a gateway, you can only enable this gateway. Sorry, this option only on the gateway where you have in a VNet where you have a gateway, right? So if you enable this, it will if you click OK, it will go ahead and create the peering. And how does the peering look like? Actually, it does look like this, right? If you create the peering, it will look like this. So I have a peer called spoke one. So let me go to the spoke one. So as you see, I have created here as well, and I have enabled use remote gateways. So this guy or this spoke will actually uses the gateway of hub network, right? So I have enabled that. I did not enable, or I did not get an option to enable the gateway transit because this particular virtual network does not have the gateway enabled in it, right? So yeah, this is how the peering enable. You can enable the peering like that. Now, once you enable this, let me show you how you can create a gateway, virtual network gateway in it. Right, so you know now how you can create a subnet. While creating the VNet, you will also get an option to create multiple subnet. In case if you forget or you want to add later on, you come here on the left navigation window, you click on the subnets. In the settings, you click here subnets, you enable the subnets, right? This is how you create the subnets. Different type of subnets. You have multiple options to associate network security groups, route tables. If you have some, like, I have a couple of routes, so you will get that option as well. So you will get that. So this is what hub and this is how you create this virtual network and subnets. Now the second option is how you create the gateway. The same way, in the search window, you type a virtual network gateway. You create here, you click on the virtual network gateway. You come here and click on add. It depends, like, if you have free trial or if you have multiple subscription in the same directory, you shall have multiple options also. So select the one where you want to create a gateway and which is the right the right subscription for you. So instance detail, this is the name where you provide the gateway. So you provide like hub 01 gateway, that way. Okay, choose the right virtual network. So I will choose the virtual network. Okay, so basically right now, let me select East US. Now I have a gateway type. So I will create, you can choose which one you want to. You want to choose ExpressRoute, you can choose ExpressRoute. You can have different type of SKU. So your SKUs are nothing but it will give you an option to choose standard, high performance, ultra performance, the types of gateway which will have more different type of bandwidths in it. So if someone needs to understand that what type of SKUs they have, SKUs is nothing but a number which will define the range of a device, that what kind of throughput or the bandwidth that they have, right? So for now, I will choose VPN Gateway. I will not go with the ExpressRoute. So this is as I explained you that there are different type of SKUs you will have. VPN Gateway 1. So VPN Gateway 1 will have different type of bandwidth allocations, that the numbers of gateways that you can connect with. So these are the options. Whichever you want to choose, you choose as per the the bandwidth you require to connect with on-prem. You have different type of generations. So it depends upon which SKU you choose, the generation gets changed, right? So this particular SKU GW3 have 2 generations, so you can choose any one of them, which one you want. So I'll go with this one only. I have a virtual network. I can create virtual network if you want. You can create a virtual network from here as well, right? So I will create like okay, resource group. Okay, it will automatically populates everything for you. Right, so it will change chooses the range of gateway subnet. You need to create a public IP for the gateway, so you can provide this IP to your on-prem network engineer. So either you create one, or let me create one. Right. So this is the public IP you created. Okay. Enable active mode is nothing but I have explained that this virtual gateway, so this virtual network gateway will have machines in it, depending upon the SKUs you choose, right? So those machines will be like one machine will be active and one machine will be always passive. There is no, so one machine will always be connected to your on-prem. In case anything goes wrong with the gateway, it will switch over. It will flip on the another machine, and that machine will get activated again, right? But it will that failover will not affect you. It will be like in seconds or a minute. So it will the tunnel will automatically comes up. But when you enable this active mode, depending upon this queue and the gateway which you choose, right? The machines gets spinned up. You will have multiple active gateways in it. So mostly there would be 3 or 4, and active gateway will enable the options for you. You can also see those options from the network. I will show you that from the effective routes, that how many IPs for that gateway is. But this is what happens in active mode. Machines get activated. You can connect with one gateway. You can connect multiple sites and create the redundant tunnels in it, right? So that's the reason it's asking me to create a second public IP. So the gateway will have 2 nodes. So you can have, 2 different sites connected to it. So for now, I will disable it. BGP ASN, it's a border gateway protocol which you connect with. Border gateway protocol which help you connect with the devices which has the BGP. Those devices also needs to have a BGP, right? So this is when you enable it, it will give you the ASN. This is the Microsoft preserved ASN. This is called autonomous system number. Again, it's a very deep topic, so I will not go into that. But 65515 is Microsoft Azure reserved number, so ASN number. So whenever you configure the BGP, you need to give these details as also. Right, so I will disable that. We'll go to next tags. It will run the final validation. It will create a gateway, but it will take almost 45 minutes. So I will not create a gateway. I have a gateway right now already created, right? Okay, let's see. What does it say? It says that subscription currently has 10 resources. So mine is free, right? So it will not let you create more than that. So it has certain certain restrictions that you can only have 4 machines in that particular region, like that. So I have a gateway, so you don't have to worry about it. Once it's get created, it will look like this. You will have a public IP. It will also show you that in which virtual network you have created that. It will also show you that what type of VPN device or VPN type you have chosen. It means IKE v2, route based is IKE v2, and policy based is IKE v1. The gateway type is VPN, right? That way you can choose ExpressRoute as well. If this is an ExpressRoute gateway, it will show you ExpressRoute here. So SKU is the one which I choose, the basic one, standard one. I have a subscription minus free trial. I have created in this resource group. Location is East US, right? So connections. Now you go to connection, or the more you want to know about the details that how does that work. This is how this queue, you have disabled the active mode. When you configure the BGP, you need to come here. You need to give this IP address. You see that? This is a private IP address which came out of the gateway subnet. I have the gateway subnet on this range. So you need to give this particular IP address to the on-prem device network engineer. So he will configure this IP on his side and this number, and then that's it. You don't have to provide the address space of your virtual network or that network or this network. Everything will be done on BGP. This is the importance, or like this is the benefits of BGP. You don't have to create anything. You don't have to go ahead and keep specifying everything in that virtual network. These two things is enough, more than enough for you to configure. Okay, sorry. Yeah, so connection here, you click, if you go ahead and if you want to create a connection, right, you need to have the information about the on-prem devices, right? So what you do is you create the gateway, like, just keep the name like on-prem to Azure. Right, now you have different type of options. VNet to VNet, it also requires a gateway. Site to site and ExpressRoute. So you choose site to site because I want to connect site to site connectivity. You have a virtual net, it will automatically populate it and lock because this is where I'm creating the connection. I will get an option to choose a local network gateway. Now, before we will keep this, I will duplicate this tab. We'll keep this option right as this. I will show you that how does a virtual network local network gets created, and then we'll move forward from there, right? So the same way you go ahead and create local network gateway. Now I have a local network gateway here. Local network gateway is nothing but on-prem configuration. So remember that. So the local network gateway is on-prem configuration. You provide the name of local network gateway. Naming convention depends upon you. You need to provide the IP address of the on-prem device, right? Can be anything. Can be 123.61. Right, anything. It means like you need to connect with your on-prem network guy. This is where you define the on-prem address space range. It can be 192.168.0.11/24. Sorry, what is it? So this is how you do it. If you have any config, if you want to, if the gateway is configured with BGP and you have a gateway and BGP enabled, provide this ASN number as well, right? This is your on-prem device ASN number, autonomous system number. This is your BGP peer IP. This peer IP is exactly the private IP. It is not a public IP. Okay, so remember that this is the private IP. So, you choose the subscription, the resource group where you want to create it. Mostly you need to create the local network gateway where your Azure gateway is, right? In the same location, in the same subscription, right? So I will not create it. This is how the local network gateway, okay, sorry, I closed it. So the local network gateway looks like this. This is how the local network gateway looks like. I have provided my details, my on-prem IP, my on-prem address space, right? This is the configuration. You can, you have the configuration here. You click on connection, and this is how it works. So you could choose anyone, whichever you want to, right? The moment you choose this, it will give you, it is giving me error because I already have this connectivity, so don't mind. I'm just showing you that. This is the PSK. This is pre-shared key. The shared key is actually important for you to, for on-prem device and the Azure gateway to communicate over IPsec, right? So you can provide this. So I will give one test 1, 2, 3. It is fine the way you want to, like whatever the password. This is kind of password, okay? So protocol. We have created the gateway on route based, right? So this needs to be chosen. IKE v2. Policy based is IKE v1, right? So Azure Easy Resource Group has already been chosen here. Free trial subscription location is there. So this is how you create a connection. Connection is important for you to connect with on-prem. So it will once you connect that, well, once you click on OK, you need to you will see that connected option the same way. Now you must be thinking like, why I have two gateways here and why I'm, because I don't have on-prem, right? So I have created a virtual network as an on-prem and his device, that virtual network gateway as an on-prem. And I created two local networks just because of that, just to show that, how, so this local network gateway acts as the on-prem network, right? And this one is acts as the local network for that. So I have created the connection. It is showing connected now. Okay, very important thing. User VPN configuration. If you want to configure the point-to-site configuration, you can also connect on the same gateway, right? You can configure that. What else? Yes, VPN troubleshoot. If you want to troubleshoot your VPN, you can see this. This is how it will show you the health of the status. Start troubleshooting. It will download the network watcher, which would be covering in the next session of ours. But this is how you troubleshoot it. You can troubleshoot this way also. You can check the resource health. That what is the health of the gateway? It will provide you the details of health history, right? At what time, who does that, what happened to that gateway? Does the VPN down or not, right? That way. If you click on reset, what happened is reset will switch the tunnels or reboot the machines in that gateway, and that's when and you will see the disconnection in that in the VPN tunnel also. In case if you don't find that, there would be a many there would be many scenarios that you will have the VPN connection showing connected, but the traffic is not flowing through. So at that time, you may need to go ahead and reset it, but it's not the viable option. Please don't do it. It will break the connectivity for sure. Troubleshoot it, right? So this is how the virtual network gateway connects, right? Um, Now, so we have virtual. Okay, now we have virtual network gateway covered, network subnet gateway. Now let me go ahead and show you how the firewall works, how the Azure firewall works. Same way you search here, right? I have created the firewall, but you can create a firewall, click on add, right? You can choose anything here, like on-prem RG, right? You need to choose the public IP address. Okay. Okay, the firewall. This is the name of the instance. Choose the correct location where your resource group is. You choose the virtual network, use existing or create new. If you want, you can create new like firewall demo. I will give that name. And then right. So this is the firewalls. Is this network? Actually, it's a network address space. Okay, so I'm creating a new one. If you want existing, you choose existing. Choose the one which you want, but make sure that that subnet, that virtual network has the virtual network means Azure Firewall subnet in it. Like I will show you. So one of my virtual network, if I go here, right? If I go to Firewall VNet, if you see the subnets. It does has the Azure Firewall subnet. It named like this. So like the gateway subnet, you need to name in that way. So if you see this, you have 10.1.0.0/22. You have the name. It will automatically populate it. You provide the name. If I give, it will not take it. You need to give bigger range than this. If I give 27 even, it will not take it. More than, must be smaller than or equal to 26. So if you give 25, yes, it will take it. So you choose public IP, the one whichever you want to, right? So if you do this, I guess it's been already used. Okay, so I had the one, but you can, if you want to create it, the public IP, you name it here, like firewall IP, right? The same way it will give you an option, but firewall skew, right? Firewall skew will always be standard. It will always be static. You cannot change it. That's the reason it's grayed out for Azure firewall. It's not for other firewalls. Okay, so you create it here like this, right? Force tunneling, we will not enable that. Force tunneling is nothing but the UDR, the custom routes that you create. You force a traffic to a certain destination, but don't do it right. We're not doing it right now. So this is how you create the Azure firewall, right? Now I will show you the public IP. How does the public IP works? See, these many public IPs I have. It depends upon the gateway IPs also we create, right? Normally, I just want to show you that how does a public IP normally looks. You can have multiple IPs. You know, while creating the resource itself, it will give you an option to choose the static and all. But in case if you found that you need a static IP or you want to change from static to dynamic, you come here, you click on add. Right, you create a new IP or associate to that new, different resource. Or let me complete this. So I will show you that how does it look. So IP version v4 or IP version v6 or both, that kind of you know, the versions is available. So these are the two versions is already available, but I'm not sure like IPv6 can be enabled for Azure load balancer, that I know. But normally people use IPv4. Skews is nothing but the so if you, in case if there is a load balancer you create, that's what it mentioned, that you know, match the skew of the load balancer. But if you want, you can use standard also. Standard has more throughput, it can accept more throughput and has more outbound connections. There is also a factor that if you have multiple outbound connection, right, your machine get throttled. So choose a skew also for the IP, public IP. You name it, right? This is how this static and dynamic assignment done. You click on static, it will be static. Keep it dynamic. Idle timeout, like what is it? Idle timeout to reach that public IP. So whenever you try hitting a public IP, sometime it just keep rolling, right? So if you set the ideal timeout, which is 9 minutes, right, it will keep hitting the traffic. You know, your device will keep accepting traffic till 9 minutes. If it's not been able to route the traffic from that public IP to the devices which is behind it, it will drop the packet, right? You provide the you can provide the DNS label name like crazy, right? It will also work. So it will, this public IP has this DNS label name. I believe the guys who worked on web apps, they can relate that. You provide the resource group where you want to create it, and that's it, boom, create, right? Now, if in case if you want the public IP to be changed, like, you know, I don't want static, I want different IP. So you go to configuration, you can change the label here as well. Wait. Okay, this is Azure Firewall, right? Wait a minute. I will go to virtual machine. Yeah, sorry, Azure Firewall has a static IP. I already told you, but I forgot. Sorry for that. But yeah, if you go to you know, any virtual machine IP or you know, anything, any IP which doesn't require to be static, it will give you an option to change it from here to static and make any changes here. Like if you want to make any changes, static, right? But that machine gets reboot. It's actually giving you the option here that it's telling you that, you know, your hub VM will get reboot. So I will not do that, but this is how it happens. You can also have the DNS label name, right? So this is about the public IP you create. Now, let me show you the route tables. Okay, yes, the route tables is important. Now, I was mentioning about the route tables. The route tables is nothing which you already discussed, but I don't want to discuss it again. But just to give you a gist, route tables help you route the traffic from one source to another source. It's like a force routing, It's like a force routing. It's like a traffic routing in a particular direction, right? So you create an add route table. You put the name where you want to. You go ahead and click East US. You put the name of it, and that's it. You create the route table. Propagate gateway routes. Propagate gateway routes, we normally choose no, just to prevent the propagation of the on-premises route. So that means if my on-premises has 192.168, that kind of address space, and if you have UDR created with this option enabled, it will go to every other, it will propagate your route, means whatever the route you have in this. I will show you that how to create a routes, but it will propagate all the routes to the virtual network which is connected with the subnet that you associate that route table to. So we normally choose no, we don't want. So I have created a gateway route name like gateway route. When you create the route table, these things would not be there. So you need to go on the settings. You need to go to route. You need to click add route. You provide the route name. That's a route table name. This is route name. Okay. So you provide the route name. You give the address prefix. This is the address prefix of the destination. So from one point to another point, if you want to push the traffic through a different firewall or a gateway, you need to provide the traffic, you need to provide the destination where you want to reach, right? So this is what you want. The next hub types are something which is like from on-prem device, if the traffic reaches the Azure gateway, and if you guide or if you tell your Azure gateway that, if the destination is for this particular address space, please send the traffic to virtual network gateway. So virtual network gateway has this route, then he will send the traffic directly to that. Else he will send the traffic to the to the address spaces which is behind the virtual network gateway subnet. So if you click on virtual network gateway, it will automatically pops out the IP address. And if you have internet, it will send out the traffic towards the internet. You have a virtual appliance, it's nothing but NVAs, which is nothing but a firewall. You provide the IP address of the firewall, and if you click none, it will get dropped. If you click none, it will go in a loop. It will not go anywhere. So in my case, I have created a route which says a destination of a spoke, and it will also says the destination of a traffic. It's a destination of sorry, not a destination. It's a Azure Firewall IP. So if you want to associate a subnet, you click here. You associate a subnet like this. On a subnet, associate whichever subnet you want to associate. You associate that subnet, right? What happens is now the traffic from on-prem reaches this subnet. Subnet knows that that I have a route which tells me that I need if traffic related to the destination 10.3.0.0/16 comes, I need to send to this particular device, which is nothing but an NV or firewall, Azure Firewall, anything, whichever you deploy in your network. So this is how you create the route tables and associate them to the subnet, right? I have to show you that how whether the VPN gateway works or not. So I have different virtual machines. Oh, sorry. So I have created different type of virtual machines here. So let me go and log into this. So I have on-prem VM and I have hub VM also. Yes, this is on-prem VM here. Let me log into hub VM. Okay, we're already at the end. I just wanted to show you something more interesting in it. Let's again be login there. Virtual machine. I did not talk about the virtual, sorry, network security groups, right? So, yep. So let me come here. If I go to hub virtual machine, right? If you want to check whether the virtual machine has the right subnet, right network security group or not, you please come to virtual machine first, right? Rather than going to the virtual network in the subnets and then check. No, come to virtual machines. You click on networking. Okay, you will see the network interface is associated with. You will also see the configuration that you configured while creating the virtual machine. Now, it will show you the inbound security rules, that these are the inbound security rules I have created, right? You can create, add inbound security rule. You can select any source. So source will have IP address, service tag, application security group. I will not cover this, but just for your information, IP address is nothing but the IP address which you will choose from a certain CIDR ranges. It will let you enter the IP address. You also have a facility to use multiple IP addresses using comma, right? So that way you can also use it. So if you click any, it will provide you need to provide the port range which can be, anything from 100 to 200 depending upon the application that you want to send it traffic to, right? So destination is nothing but any, again it's the same options, like what if you want to send the traffic from virtual network to virtual network also, you can allow that. Destination port range, once the traffic reaches, what port is going to get hit. The protocol, as I said, 5 tuple protocol will be TCP, UDP, and ICMP. Allow, deny, and the priority. The priority, the more you choose, you will, the lesser the number, the higher the priority. That way, you can provide. This is here. You provide the name of the security rule. Now, the moment you come here and you want to see that with which it is connected, with which subnet is connected, you click on the network VM hub NSG. Okay, it will take you to the exact NSG page, right? And it will show you that with which subnet it is connected with. Right now it is not connected to any subnet, right? So you need to associate that subnet. You come here, you click here, and you click on the subnet where your machines are. So let me select this one, and this is the one. So this is the way it will associate a subnet. Make sure that you will have these options. The NIC would be associated with the NSG, but sometimes subnets would not be associated to. So just do the rechecks every time whenever you find the issues. You can also come here and select, add the rules here, right? Like this, the way I showed you before as well. Or also you can see the default rules which has already been applied, right? The outbound security rules allowed in the same way, so you don't have to do again and again the same situation, right? So this is the thing which you can associate a route table. You can create the NSGs, hub and spoke architecture, local network gateway with it. Now let me log into hub machine so I can show you that the VPN connectivity works or not. So first of all, this directly command prompt will not open, but yeah, this is the configuration manager which I have configured. Like the machine will open it with these features. Just in case if you want, what you can do is you can go to always firewall, right? With the advanced security option, you come to inbound rules. Sometimes for the normal connectivity check, mostly people will do the IP, the pings, right? So the pings will not be listened on every other machine. So the ports are not open for the pings to be listened on. So what you do is you first go ahead and enable this feature, file and printer sharing echo request. You right click, it will give you an option. Right now I've enabled it, so it will not give you an option, but it will give you an option to go ahead and enable it. So this option will be enabled, and also in outbound you enable the same option, file and printer ICMP v4 out. So there is ICMP v6 as well. So you enable this option, and it will help you to do the quick testing. So right now, oh sorry. Right on 10.0.0.4, which is nothing but a hub network. I will go ahead and do 10.4.0.4, which is the on-prem network. And you can see it's actually pinging because we have a gateway enabled in it. So guys, I hope you guys understand that how you can create a gateway, virtual machines, associate the subnets, route tables in it, and how you can create the virtual network gateways and local network gateways in it. Yeah, this is it. If you want, you can just do the cross check from your on-prem also, like, so that was 10.0.4. Yeah, it's going bi-directionally. The traffic is up, and just to check whether is it really going or not, you come here on the gateway, virtual network gateway, click on connections, right? You will see data in, data out, right? You will see data in, data out. A quick tip, a very quick tip for more troubleshooting in case if there is any issue, you go to a virtual network. Go to virtual network and then a virtual machine. In a virtual machine, you see the effective routes. Effective routes is actually tells you whether this machine is being connected or not connected, or can be reachable from on-prem or spoke or anywhere or not. Let it load. I will show you. I will tell you that. Okay, great. So you see 10.0.0.16, it's the on-prem network. Sorry, it's a hub network. This is my VNET Peer spoke network. This is my on-prem network, right? This is my internet network. These are my RFC defined IP addresses, which is default been allowed automatically, right? So you see, this guy knows how to reach my gateway. This is my Azure gateway. I will show you just to confirm you the same. '52 to 55, 165, 103. You see, on-prem device or virtual network knows that how I can reach. I am on my hub virtual net machine, and I have seen the effective route. So this guy know how to reach on-prem and how this guy can reverse traffic from it, right? So this is how you can check. In case if the routes are not there, that means there is an issue. You can check that. Effective security rules also you can check it for a machine to troubleshoot more in depth, right? Yeah, so absolutely. Yeah, this is it from my side. And I thank you so much for joining the session. Ashish, you can please take over. Neeraj?
Oh, okay. Yeah, thanks, Rahul. Thank you so much. It was really informational and a very deep down thing, as you may expect from a networking session. Network in Azure, or in general, is a very complex topic, and it is very difficult to cover everything in 3 hours window. But we really, I mean, it was really great session. So and we also have everyone, if you want to go more details into the Azure networking, we have conducted network sessions in past. We will highly recommend you to go to our YouTube channel and watch our networking session YouTube playlist. It was a little old videos. I mean, you will find certain things which are obsolete or may not be applicable in current cloud scenario. I mean, current Azure services. But that's where, Rahul, today's session will come into picture, where you can supplement it with the latest things that are working today. So and this is how we are trying to help you to prepare your examination. And as we have been telling, these sessions are multiple sessions covering multiple topics in each session. This is, I mean, this was today's session was fifth session in that series. We still have 3 sessions in this particular track, which we are going to cover in next weekend. in coming weekends on next Sunday, same time. So if you have not registered for the next sessions, we highly recommend you to register for the session. And also, please join our Telegram group to get updated with the recordings or slide deck links and any other future updates that we will be announcing about the trainings that we are going to conduct. All our trainings will be free in future. We are already planning to conduct DevOps training. We already have a plan for conduct Azure Architect track. So if you are part of our Telegram group, you will automatically get all the details required for those trainings. One thing. The second thing is our Telegram group have more than approximately 8,000 people over there from different parts of the world, having different expertise in different services in Azure. So you can, we highly recommend people to post their questions. It can be as simple as getting started with the cloud, or it can be as complex as when you are implementing a service in Azure and you are facing some issue. We do not commit for some timeline for the responses because it's an open community. Anyone wants to answer, they can pitch in, but be sure that there are a lot of experts in different aspects. They can pitch in and help you there. So Neeraj, you want to complete something before we close for the day?
Sure. So it was a nice session, and then I look forward for participation. So this was our fifth session, right? So as Ashish said, so we have multiple sessions. We have 3 more sessions lined up. So don't forget to. So you can go and sign up for our sessions. So you can go on to azureeasy.com/az9, not sorry, az104, and there you will be able to register for your sessions. So our upcoming sessions, plus also the URL to join our Telegram talk is t.me/AzureTalk. So please make a point to join our session, join our group there. And all our past recording, if you can go on azureeasy.com, you will see the listing of all the recordings. So that's one place where you will find all the recording, the information, how to join the groups. We have other groups also. We have DevOps group, O365 groups too. All those information you will find over here. Plus, you will also have the information about the upcoming event. So please do visit that website. In addition to that, we have our channel is Azure Talk. So if you go to youtube.com/Azure Talk, that's where you will find all those details. And if you want to connect with us, these are our LinkedIn coordinates. So you can connect with me, linkedin.com/in/Neeraj. So that's something you can connect. If you want to connect with Rahul, these are his public coordinates, which is Rahul.Mathuria. So, feel free to connect with us. And if you have any questions, don't shy away, join our Azure Talk group and post your questions. It can be a very simple question. It can be a complex question. People help each other. And yes, this is a community group. So don't expect a time bound or SLA bound answer. People try to help each other. If you have a critical problem or production downtime, so then probably I would suggest you contact Microsoft directly. But yes, if there is something that you're looking for, you have time on your hand, you can post those questions there. And in case we were unable to answer any of your questions, please do feel free to post those questions into Azure Talk group, and our experts, our Azure Easy team members, as well as other community experts member will be able to answer your questions. So with that, we'd like to thank everyone for joining our session today. I want to thank Rahul, I want to thank Ashish, Vipin, and all the audience for joining our session today. Don't forget to join our next session, which is going to be next Sunday, 7 p.m. IST, and which will be 6 sessions. So we have 3 more sessions for AZ104 lined up. So thank you once again, and have a good night, and have a great weekend. And we'll look forward to talking to all of you in our next session. that is on next Sunday, 7 p.m. IST, which is 9:30 a.m. EST. Thank you, everyone.